I'm sorry to late for start. Hello, Datadog Dash. I'm truly honored to stand on this stage. Huge thanks to the organizer for this opportunity. I'm Shota Yomi, a platform engineer at Numo. Today's talk is Monorepo error management, Runbooks, and team-targeted alert distribution. My promise to you, you'll get a simple way to help anyone respond to alert right away. OK, before we start, let me ask you something. Have you ever woken up, opened Slack, and found your alert channel full of new error messages? The channel exploded overnight, but nobody checked it until morning, sometimes never. When this happened, this question came to mind. One, what happened? And an alert is just a signal. So I needed to check that what's actually wrong. Two, who owns it? In the microservice monorepo, ownership shifts often. Yet the team that built the service must read the response. Three, who's on it? Maybe the same error was triaged last week and marked as a low impact. Do we know that history? Four, what's my move? Which dashboard or logs do I open first? And how bad could this get? So here are today's takeaways and keywords. First keyword, priority-based triage. When products and team grow, organizing alert correctly is important. With a single repo, the number of services grows first, so labels and prioritize must be crystal clear. I'll show a monorepo-friendly way to achieve that. Second keyword, runbook, but done the right way. Big teams create silos. Alert handling becomes person-dependent. But keeping runbooks up to date is very hard. We'll see how to manage runbooks declaratively and have them delivered automatically with every alert. Third keyword, GitOps workflow automation. All alert logic, docs, and rules are managed in Git. Change goes through pull request. GitOps automatically applies them. This makes it easy to track, change, and see the current state. It works great with Monorepo. These 3 points will be our focus today. OK, now I should introduce myself. Hi, I'm Shota Iwami, a platform engineer at Numo. The icon in the top right is a picture of my dog, Kotetsu. I often use this icon on social media, so if you see it, please feel free to follow me. I'm especially interested in technologies that boost developer productivity. Of course, I'm passionate about observability tools like Datadog, but I'm also very interested in approaches like trunk-based development and feature flags. If there's ever a chance, I'd love to talk these topics as well. Like I said before, I have 2 dogs. The black Shiba Inu is Kotetsu, and the brown one is Himawari. This is the reason I love Datadog. Just kidding. But I really do love both of my dogs. They both have wonderful smile. They're both very good friends, or at least I think they are. I hope I can be friends with Datadog too, so it doesn't bite me. OK, now let me tell you a bit about Numo. Numo is a mobility and fintech startup that was just founded in January 2024. We develop and operate a platform based on taxis and ride sharing, and we also offer car leasing services for rideshare drivers. But taxis and ride sharing are just a start. Our real goal is make mobility better and make region, especially rural area, more active and careful. So we are also working on other transportation area. Now, for some background, let me quickly explain how we are set up at Numo. As I mentioned, we are a mobility startup with multiple products. Including our taxi group companies, we have over 1,000 people, but around 50 engineers work in development. Sorry. All of our code is managed in single repository and Monorepo, and people move easily between different projects. Our operation teams and engineers work closely together to handle incidents, so business and engineering work together well. Because of this, we don't separate our channel by project or product. Instead, for each environment, development, staging, and production, we have a single channel that everyone monitors. In this situation, NIM had several problems. First, the error channel became noisy. In the early days of the startup, development was the top priority. So there was never really a culture of checking the error channel. We just error notifications, but no one watched them. This made the channel noisy. Sometimes people even muted notification completely. Second, it was not clear who owned alert and errors. People moved between teams often, and some people worked on multiple teams. So when an alert came in, it wasn't clear who should handle it. Even if someone saw an error, they didn't know which team should fix it. This made handling alert much harder, and most people stopped checking the channel. Finally, there was no clear steps for troubleshooting. There was little information about how to respond or what kind of error it was. So people had to carefully look at each issue to figure out what to do. Very hard work. Also, even if a similar error happened before and was already triaged as low priority, we had no record of that decision. So every alert had to be looked at from the beginning. This means that very important alert could easily get lost in the noise. Because of this problem, we realized we need to completely rebuild our alert channel. Yeah. There is a well-known theory in environment criminology called the broken window theory. This theory says that if a broken window is not fixed, it becomes a sign that no one cared. This encourages more windows to be broken and eventually makes the area less safe. This works for other things too. The same is true for alert channels. Just as a single broken window shows that no one cares, a single alert left untriaged also shows that no one is watching the channel. To change this, we need to completely rethink what an alert channel is. Okay, there are two main approaches I want to show you today. I worked on both of these myself. One is automatic runbooks generation, and the other is team-specific alert notification. I'll explain both of these today. Let's start with automatic runbook generation, a declarative approach to managing runbooks. Okay, before we move on, let's compare a world with procedures and a world without procedures. In a world without procedures, when you see an alert, it's hard to know where to start. As a result, issues tend to be ignored. This happens because the cognitive load is high, and when daily development is busy, it's difficult to keep up. On the other hand, what about a world with procedures? Procedures clearly highlight the key point for responding, so you can take action right away. They also mean you don't need to rely on specific people, so more people can step in and help. As a result, more people are able to maintain order in the alert channel, and team members can support each other. So procedures have many benefits. The procedures I mentioned are called runbooks. As I described in O'Reilly's book, Practical Monitoring, it's impossible for everyone to know everything about complex systems. By writing procedure in Runbooks, we can share knowledge and help more people respond to alerts quickly. In other words, having documented procedure, also known as Runbooks, help prevent silos. I'll be talking about how great Runbooks are, but let's be honest, you probably already know about Runbooks, and you probably have some headache with them. There are several challenges when we actually try to use them. First, documentation tends to become scattered. Runbooks are often managed separately from the implementation code in tools like Notion, Conference, or Wikis, and they are almost never tracked in Git. Second, it's tricky to get to Runbook from logs. It's common to include a code in error logs to connect them to Runbooks. But finding this code in the logs and then looking up the right Runbooks takes time, which is extra work. Third, adding rich message to logs increases log volumes. To avoid having to look things up by hand, you might try embedding detailed Runbooks information directly in error messages. However, the more detail you add, the larger your logs volume. So we can't just keep adding information forever. Let me show you this with an example. Imagine you add a code to your error messages to connect them to Runbooks. Each error notification will then include this custom code. So when you want to check the right Runbook, you have to use this code to search for the matching one among many Runbooks. So putting codes in errors but keeping Runbooks separate makes both lookup and maintenance harder. This is where our solution comes in. One Runbook for all alert flows. First, here's an example of what typical Runbooks looks like. We call our custom code reason code, assigning a unique code to each Runbook message. For each code, we write down the steps to handle the matching error. Until now, this information was managed in tools like Notion, Conference, and GitHub Wiki. Now, let's see how we solve this. We solve this problem with automation by generating everything automatically. We call this approach Go Generate. OK, let's start with an overview of the architecture. I'll walk you through each part step by step. OK, before we dive into the architecture, let me clear about our why. We want all the benefits of the Runbook without the maintenance nightmare that usually comes with them. The goal is simple. Change something in one place and have it instantly reflected everywhere. In your code, in your documentation, in your monitoring alerts. No more updates all over the place. No more gaps between what's written and what's real. Keep this in mind as we look at how we build this system. OK, first, let's focus on the most important part, the prot file. We decided to store all Runbooks in prot file and manage them with Git. Runbooks are kept only in this prot file. By the way, we choose prot files because we develop a prot.c plugin as a part of our ecosystem. However, any declarative Git-managed format would work. YAML, for example, is also a good option. And we are actually planning to support YAML in the future. Now, let me show you an example of how these prot files are set up. First, let's talk about the reason code. This is a unique ID file assigned to each Runbook. Actually, this code becomes extremely important later when we integrate with Datadog monitoring. But I'll explain more about that later. Next is message, the main body of the runbook. This section describes the actual steps to take, linked to reason code I talked about. Just like the reason code, this information is also important for Datadog monitoring. All of this is defined in a single plot file. If you are working in a monorepo like we are, you just put this file in the same repository. Next, let me show you an application code file that gets generated from the plot file. Since we use Go as our development language, I'll show you an example generated in Go. However, because the plot file is the source of truth, so you can automatically generate it code in any language you like. First, let me explain the generated code. From the plot file, we automatically generated constants for each reason code. To make them easier to reference in IDE, we include the runbook contents as a comment next to each constant. This approach prevents typos that might happen when typing reason code as strings during error handling. Next, let's look at how the reason code is actually embedded in an error. By defining the custom error type to accept only the auto-generated reason code, you make sure that only valid reason code constants can be used. This way, every error connects to its reason code. Here's what the JSON looks like when the error we just embedded is output as a structured log. The reason code we have attached shows up as an array in JSON output. This detail will become important later when we configure Datadog monitors. Now, finally, let's talk about how to set up error monitoring in Datadog. In Datadog monitor notification message, you can use conditional variables. I'm sure many of you already use things like isAlert to wrap the Slack notification section. Actually, there are several types of conditional variables besides just isAlert. For example, there's a variable called isMatch, which allows you to write if-like conditional statement. We use this feature in our approach. By using isMatch in our messages to check the reason code, we can branch the contents of our alert notification. For example, like in this code block. We can access the log field, log, attributes, error, reason code. And if it contains a reason code like RC50, we can include the matching runbooks in alert notification. This way, instead of sending the same error messages for every error, we can customize both the notification and the runbook contents based on the specific reason code. So that's how we use isMatch to branch our alert messages based on the reason code. Pretty cool, technically, right? But I can hear some of you thinking, OK, I get how to this work with Datadog. But so what? That's exactly the right question to ask. Let me show you what this actually means for your daily life as a developer. Let me be honest about what we start with. Our alert channel was essentially a digital wasteland. Look at this poor guy. Drawing in garbage notification, surrounded by random noise, ignored message, and chaos everywhere. Alert, errors, more alerts, just floating in this digital ocean of despair. This was the reality. Our alert channel was a place where notification went to die. But now, look at this transformation. The same character, the same channel, but everything has changed. Instead of drawing in garbage, he is now surrounded by beautiful gift. Each notification is now a smart gift arrived with perfect timing. 500 switch error from full system. System error is down. A full error occurred. But each one comes with its own built-in solution, actionable guides, and instant query. We've transformed the most worst place in our workspace into a treasure chest of actionable intelligence. This is the power of automatic runbook delivery. Now that you've seen the change from Westland to treasure chest, let me show you how we built this system. This is how it works with our infrastructure as code approach. Notice that Terraform file generated is highlighted. This is where automation does the work. Remember our why. Change it once, instantly reflected everywhere. This architecture does exactly that. Let's dive into how each piece works together. We have seen that we can use isMerge to create conditional branches in your message. But as you can imagine, writing and managing all those message variation by hand would be impossible. That is where infrastructure as code comes in. Datadog monitoring supports Terraform, so we automatically generate the message content, including all isMerge branches, based on the plot file. For this automation, we generate a markdown file that contains the isMerge logic for all our messages, and then load it using Terraform's built-in template file function. This approach lets us handle even complex branching message with isMerge at zero maintenance cost. Here's an example of an actual alert notification that was sent. You can see that the code block contains the runbook corresponding to RC50. All of this information is managed in a single plot file, and the runbook contents is actually embedded in the notification based on the reason code. So there's no need to look anything up manually. Since everything is managed in Git, any changes to the plot file are instantly reflected everywhere as soon as the pull request is matched. By managing runbooks this way and using automation, we avoid a big logs and scattered documentation. This way, rich error messages are delivered instantly, enabling more people to take action the moment they see a notification. One proto to route them all, one proto to find them, one proto generates them all, and in the code binds them. Just as the one link was made to control all the other rings of power, our single plot file brings together and control all the scattered pieces of our runbook system. Now that we have conquered runbook chaos, let's tackle our second challenges. So far, I've talked about automatic runbook generation. Now let's turn to the second approach, chain-specific alert notification, making sure alerts reach the right chain. Like I said before, at Numo, we develop in Monorepo with multiple chains working in parallel and people frequently moving between chains. Because of this, we needed to know which component an error notification was related to and who owned that component. Our first simple idea was to use the component name included in the logs. In practice, this component name basically matched to the chain responsible for development. We thought we could create Slack groups like alert, Slack, component, and service name, component name, and use the component name from the log attributes to mention the right group. However, this approach didn't work as expected. Those of you who have used this feature before probably know that in Datadog, when you want to mention a Slack group, you have to specify the group's ID, not its name. You need to use a format like substring plus the group ID. This means we cannot simply get the group name from a log attribute and use it for mention. We must use the matching group ID. However, this information isn't available in the log. To make this work, we would either have to create separate monitor for each component or use its match logic to branch the notification, like I showed before. That's where Datadog's reference tables feature comes in. We solved this problem by mapping zero relationship in a CSV file. Let's take a closer look at how this works. First, let me briefly explain what reference tables are. Reference tables are a feature in the Datadog that lets we add metadata to information that's already in Datadog. By uploading data in CSV format to Datadog, we can add metadata field to logs and other data. We can upload the CSV manually, but reference tables also support cloud storage services, like S3, GCS, and Azure Storage. If we update the file in one of these storage locations, Datadog will automatically sync the changes. Here is how we apply these features. First, we created a CSV file that maps Slack group ID to service name, and we manage this file in Git. When the prerequisite updating the CSV is managed, the GitHub action uploads the new CSV file to GCS. Datadog reference tables are configured to watch this file, so any changes are immediately synced. This way, the Datadog's reference tables can keep the mapping between component name and Slack group IDs. All that's left is to specify this in the lookup processor. By using the synced reference tables and setting the component name as the key, a new field called Slack group ID is automatically added with the right ID. At this point, all we need to do is reference log attributes Slack group ID after substring, and we can use group ID to mention the right Slack group. Here's an example where we could mention the right group for each component using the group ID. There are actually quite a few benefits to using group mention. This main benefit can be summarized into 3 points. First, it becomes easy to spot priority alert for your group. Because we are only mentioned for alerts that matter to us, we get less distracted by noise in the alert channel. On the other hand, we'll be much more aware of error for components we own and need to check. This greatly reduces missing truly important alerts. Second, owners are instantly notified via Slack mention badges. If we are in meeting or working on something else and can't respond to alert right away, you'll see a badge showing the number of unread errors, making it easy to keep track. This makes sure you won't miss important alert even when you are busy. And finally, escalate is possible if owners don't respond. Since we can see who's in each Slack group, if we come across an error that doesn't belong to us and hasn't been checked by anyone, we can quickly escalate it to the right people using our mention. And because the original alert notification includes the mention, if we start a conversation in the thread, everyone in the group will be notified. So won't miss important discussion just because we want individual mentioned. In this way, making proper use of the mention can really improve how teams respond to alert. Now, let's wrap up. In this session, I discussed two main approaches. The first was automatic runbook generation. By using automation, we could embed runbooks directly into alerts and manage them in Git, making sure that updates happen instantly and everything stays in sync. This approach let us deliver rich notification while keeping maintenance as simple as possible. The second approach was team-specific mentions. By using reference tables to map components to their matching Slack group ID, we optimize how mention works. This makes sure that alert always reaches the right team, reducing noise, minimizing missed notification, and helping team member feel more responsible. This day, when it comes to observability, it's easy to focus on advanced features like APM. But I suggest you take another look at your alert channel. If you notice any broken window, I hope you take steps to fix them. I hope some of these ideas from today's session will be helpful as you to do. Thank you very much for listening. If you have any question, please feel free to ask. But please keep it friendly. Let's change our question from biting to kissing too. I'm hoping for questions like the right side, not left side. Thank you.